thank you for keeping strong and staying here. It's late, quite late, but it's good that we're here. So far, what we've seen the big picture, right? We've seen how pieces of code are connected together. What is the best way to keep them connected, keep them maintainable, keep them moving forward with the requirements of your domain, right? And sometimes the requirements change, and therefore we have to keep those pieces glued together in a way that our efforts are not so great to change them. But now, we're going to talk a little bit about clean code. Well, we've looked at the macro in the past presentation. So right now we're going to take a microscope and look at what's inside. What's inside a class? How do we organize a class? What names do we give it? What goes inside there? Well, at least we're going to talk briefly about some things. It's quite impossible to cover all of it. But we're going to talk about some nice and cozy, funny things at times. Okay. Right. So let's start with a disclaimer. These are my own views. Highly, I should have highlighted highly, inspired on the work of Uncle Bob. Uncle Bob, as you know, Matey here already mentioned him on his presentations. I was talking to Sergey. Sergey, by the way, is the architect of our team in Texas, and we were kind of discussing this. Quite funny because all of these names they keep coming up. Uncle Bob, Martin Fowler. So I mean, if you want really the nice stuff, the creamy stuff, you have to look up those names, or at least start from there. Right. Okay. It's going to be a little bit of reflection of the past year that I have spent in Texas and how I changed the way I code. So I'm going to share a little bit of that with you guys as well. So we're going to look at some simple examples and move on from there. So I've already mentioned that, we're only going to touch the surface. So here are a few quotes taken from Uncle Bob's book, Clean Code, by the way. So, which is quite right if you look at it. And if you can write code that a computer can understand, but the bigger point is, can other people understand the code you write? I mean, how easy it is for other people to understand what you're trying to say in code? Because when we write code, we're nothing but transferring our thoughts into code. So how easy is it for other person to look at your code and see what did you meant to say on that, right? So that's what I think it in essence is. Well, and there's another funny quote here from Martin Golding saying that basically you should always code as if there was a psycho tester coming up and looking at your code. So in that way you feel threatened and you're not going to let your guard down. You're going to look at your code and you're going to try to make it as best as possible. Right, so we're going to do one exercise now. Please start now. I'm going to give you some time. You're going to look at this code. This code has been slightly adapted. Maybe there from the back you won't be able to see it, but there's some space here. If you feel that you want to come closer, please feel free to do it. If not, just let it be. So yeah, have a look at this code. Examine the code. I'm going to give you another minute or so to have a look at it, and then I'll just move on to the second page.
Too long.
Please, 8 space sequence.
Let's move on. I promise you that's the last one. All right, maybe enough. Right. So the question is, did you really understand that code in the time that was given for you? Do you have any idea what the code was doing? What was it doing? Any idea?
Rendering the page.
Wiki
page.
Right, that's all. But what kind of page was that? What was the goal of that function?
Wiki page.
Well, yeah, there was some kind of wiki thing going on in there, and then appending strings, combining everything together, and making some tests and tearing down things, constructing things up in there, checking some Boolean flag to know if you should be doing something or something else, all in that, all crammed down together, vomited in that piece of code. And that was it. So that code was doing too many things. There was so much going on in there. Mate here, he didn't even bother to look at the second page. I spotted you. So, how about this one now? Is it easy to give up on this code? Or is it harder to give up on this code? How easy is it to understand this code right now? Better? Any better? Somebody disagree? Thinks that it's worse?
It's still too long.
Too long, that's quite right. So it's a little bit better, but we can definitely improve on that code. Sorry? Well, as well, for starters, when you have in this case, each suite is a Boolean flag. So when we pass on a Boolean flag to a function, right? Well, basically what we are trying to do is we are saying, okay, I'm going to call this function. If something, do this. If not, do something else. And that's, oh, we know that's wrong, right? A function should be doing only one thing. So now you had a look at that. You kind of understood that I was creating a test page, loading up some test requirements, executing the test if it was a test page or not in that wiki page, and then later on tearing down everything from the test and then rendering that page, right, into HTML. So what is it that makes a function easy to understand? What is it that makes the code easier to understand? By trying to communicate intent. How is that possible? I mean, what kind of attributes can we give to the function? How can we shape it so that other people are going to look at it and easily understand it and not waste time? Yeah, we're going to talk about functions. So, what is the first rule of functions? Anybody? Come on, it's easy. It's there.
I think naming is very important. Why it's not like the first. One of the problems is that like that naming of anything, classes, functions.
As well, that was the point. But do you remember the name of the first function that was shown before the refactoring? What was the name of that function?
Yeah, it made no sense.
So it was saying that it was rendering a HTML page. Yeah, you can argue that that was a good name, but well, maybe not so much because it was doing so much more than that. Right? So you're quite right. Yeah, name is important. But the functions have to be small. They have to be very small. Because if a function is very small, you can name it, you can't get it wrong because it's only doing one thing. And therefore you can give it a very good name, put those pieces together, and make it work in a way that, you know, it's just, there's no doubt. There's nothing to ask there. I mean, it's just obvious, right? So it has to be small. It has to be smaller than that. Try to keep them small. So, what is the definition of small? Right. I mean, maybe you can't notice that because I dye my hair, but I'm quite old, so I've got gray hair. Back in the 80s, we used to have a VT100. That's a terminal, Unix terminal, and in there, we could have only a few lines. So the definition was that those code that could fit in a full screen was enough, was the right size for a function. Well, obviously now we have fancy computers, we have retina display, and we can fit in a lot of characters in there, right? So that's going to be like a huge function. So we probably have to change that definition a little bit. So a function should not be 100 lines long. They should hardly ever be 20 lines. They have to be small. Indeed, if we look back at the function that we just refactored, we can move on and make another iteration so that that function shrinks even more. So now, there you go. That's the function, same as the first one, doing exactly the same thing. And how hard is it to understand this function? What does it do? What does it do? Come on. I mean, that's it.
Page.
Sorry?
Include, setup, and tear down page in test page.
Well, almost. Let's read it together. So it renders the page with setup and tears down. So actually the main goal is to render the page, but how does it do that? It renders the page first by setting up everything that is required for that test to run, and then it tears down everything after the test has run and then renders the page. So, if we think about that concept, that the functions have to be very small, what's going to happen? What's going to go inside those if, else, while, and so on blocks? How small are they going to be? If you think that a function has to be very small, how small were those blocks are going to be? Pretty much about just one line, right? Because the function is very small. I can't make that stuff very big. So, which brings to the next point. What's going to be inside those blocks? Ideas? Another function calls. So what we're going to have is basically just functions inside functions. Call it other functions, calling another functions in functions in functions. We call it programming. So when your function is very small, it's not only easy to keep it small, but also to add value to that function. How do you add value to the function? By choosing good names, so that when you look at a function, it's kind of boring, right? You look at it and say, oh yeah, this name of function, so it's probably going to do this, and then you peek inside because you don't really believe it, and then you see, oh yeah, it's going to, set up the pages, run the test, tear it down, run it, oh yeah, it's doing exactly what it said it was doing. Which brings us to this point. So basically, when you looked at the first function, you had everything vomited in there. It's the same thing as like when I was small, I had all of these clothes underneath my bed, and my mom would come over and say, "Hey son, you shouldn't really have your clothes like that. You should take them nice and neatly because I take my time to wash them. So please stack them up to really nice and neatly in the wardrobe so that everything could be in order nicely and you could easily find whatever you want." But I decided not to. But you keep delaying that until it comes to a point when you finally around 30 and then you're not getting any girlfriends because all your underwear stink, and then maybe you have to decide to change your strategy a little bit. Or maybe you get lucky, you get married, and then your wife doesn't do the job but tell you to do it, and you have no other option. So in that case, how things are going to be? Things are going to be very well, nicely stacked, neatly organized. You're going to have drawers, you're going to have cabinets, you're going to have all sorts of things to put everything in place where it should really be, and will be easy to find, easy to understand. If you ask somebody, oh, can you look up at that place and get my black t-shirt because I need to this and that? I said, oh, no problem, let's go there. T-shirt will be there where it's meant to be. In addition to that, what happens when you have some nicely drawers like that? We can put a label on there. The same as functions, right? Functions, you can name them. Name them in a way where it's obvious, where it becomes not possible for you to miss something from that. So, what that implies? That implies that functions should be really small, and I keep hitting on that point because it should be small enough not to hold nested structures. So if we don't have nested structures, meaning if this, else that, if, switch this, switch that, what is the indent level going to be like? If I look at the side of a function, how is it going to look like? Is it going to look like a saw, like in the first function? No, definitely not. Maybe just a slight grid there, but not much more than that, right? What we accomplish with that, it's going to be easier to understand, because when we look at something big, something with all the wrong names, something at times in comments in Indian, I'm not going to touch that stuff. I say, no, sorry, I don't want this job. So, the function should do only one thing only. So we can kind of apply the same principle that we heard in Solid, apply that to the functions, and then the functions will be doing just one thing. Only one thing is not hard. You can do it well. You can do it only. So, when we were looking at the first code, it was doing a lot of things. It was creating buffers, fetching pages, searching for inherited pages, rendering paths, appending the arcane strings, and hashing, banging all together, combining that stuff, generating the HTML, and among other things. So, the refactor code, the one that I shown you before, it's quite easy to understand because it wasn't doing much, right? It's just that. You look at it, you know what's happening in there. If you want to reach a deeper level of detail, you just control-click. Control-click, 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 control-click like crazy. All right. But even the last one that I've shown you, yeah? How many things does that function do? You could probably argue that that function was doing 3 things because it was first checking this Boolean flag, and then if that Boolean flag was true, it was doing something else. Okay, so we probably have to find a better definition of one thing, right? So, we have to look at the level of abstraction of a function. What do I mean by that? Level of abstraction of a function has it got the same level of commands? Is it treating only domain-specific commands, or is it manipulating strings, open the buffer, communicating with I/O, and appending strings and bashing all of that together? If that is so, then you have to make them smaller. Another way that we can look at it is using this technique here. So this is quite similar to what I've found on Cucumber when I first started using Cucumber. I got amazed with that because that was the first time when I looked at the function test, which kind of really translated grammatical things. You could really like write a sentence and the code behind the scenes will be translated to what it actually is. So here we can do the same exercise. So, in order to render a page with setups and teardowns, we check to see if the page is a test, and then if so, we include the setups and teardowns. In either case, we render the page in HTML. So we can see that the levels of abstractions are all the same. So the function is indeed doing one thing, and one thing only. What do we gain with that? By breaking down things into different functions, stacking them up nice and neatly so that they come in a certain order. We're using decomposition, right? Decomposition is good because you can break down a big problem into some small problems and then layering everything down together so that you reach to your final point. So, everything should be clear. the first step of refactoring, we could see that that was not enough. So we have to be vigilant. We have to be vigilant in a way that we have to really look at our code, not be rushed. Because, you know, sometimes you just feel like you have to get that stuff done. Well, sometimes not really your PO or your team leader breathing down your neck, it's yourself. You know, so once, some time ago, I can't really place it, but I went to one of these Latvian developer network workshops. It's a quite great group, by the way. And they were doing such an exercise that you could, you had a kata and then you had to work on this kata, and but the goal wasn't really the point where you had to reach and finish everything. It was more about the journey. How do we make things? How do we structure those things? How do we put them together? Are we on the right way? What's the right way? The right way is not to go fast. The right way is to go well. When you go well, you go fast. If you go fast, you're rushing, just typing that stuff like, oh yeah, I can really touch type very fast. That's probably not the right way, right? When you feel that you are in the zone sometimes fools you, because you're not stopping to take one step back and like look at your code and say, am I right about these assumptions that I have right now? Or is it something wrong? Am I taking the wrong path right here? So, coming back to this, so you should really shrink your functions. Until what point should I shrink my functions? I should shrink my functions to the point that I can't really shrink them anymore. I can't extract anything from that function in a way that whatever I extract is going to be a merely statement of what is going on. So how can you tell that a function is doing more than one thing? How can you tell that function is doing more than one thing?
If you can extract a function.
You've been paying attention. You can read. Points for you. So, now we ask ourselves, just breaking down the functions, just throwing them there in that, perhaps in that class, is that the only way to go? No, not really. You not only have to break down those functions, but you have to place them neatly so that it kind of becomes like a book where the timeline is pretty much sequential. There are no jumps in there, right? So the story has to start. It has to continue sequentially, chronologically, to the time that the story is finished. And that's how the functions should be placed. But by the way, that's so that all the functions have a forward reference. But having a forward reference in all the functions sometimes can be a little bit tricky. So yeah, it's pretty much like a news article, right? So what happens in a news article? So you have the title, right? Then you have the summary, which is adding a little bit more detail to that story. And then you have the first paragraph. The first paragraph is going to introduce you to the subject. It's going to introduce you to that story. And then you just keep on going, reading that stuff, and then each paragraph is going to give you even more detail into that story. So that's how we should try to organize the function, so that somebody can take their class, starts reading from the top, having a look at all those doc blocks. Yeah, like this, should do that. Yeah, first function, highest level of obstruction, public functions, then keep going down, maybe another public function, then some private functions, and then private functions underneath the private functions, and so on and so forth. What do we gain by that? So your code becomes readable, it becomes understandable, it becomes maintainable. So now we can take the same sort of approach and read those abstraction levels so that you can see that those three functions breaking down here shown on bold. So if we read that, we're going to translate that into code in something like to include the setups and teardowns. We include setups, then include the test page content, then include the teardowns. To include the setups, and now you see that this function was already there on the upper function. So you kind of get the idea, right? I don't have to read all of that, right? No. Right. Who has seen this kind of code? I call it Street Fighter code. I love it when I see it. I remember the time when I had my Super NES and I was playing with Ryo and Ken. That's you know, no, don't get upset. Sometimes it brings me sweet memories. Right, going back to your point. I remember you raised that point. So what do we have? What can we do in addition to that? Since we've broken everything up and we stuck them all nice and neatly in a certain order that makes sense, we can give those functions some descriptive names. We can basically name them to correspond to what they actually do. So that if you read a function, it becomes very easy for you to know what's going on in there, right? And you can go crazy with that. You can make the names very long, right? Especially if they are private functions that are only going to be called inside, because you're not going to use them very much anyway. Maybe the public functions may be trying to keep them short, but in a way that they're not too short, right? So, if we look back into the example we had, we started from test.html, which doesn't really tell a story of what was going on in there, to render page with setups and teardowns. So now let's think back. If I step into that function, the second name with the second name, so I look at the function name and I go like, yeah, render page with setups and teardowns. What if I look into that function, somehow I had forgotten, I had deleted by mistake the function call to teardowns? I'll be like, yeah, this function is very short, I can just read it in a few seconds. But I mean, I'll be confused because I'll be like, the function says that it renders a page with setups and tears down. I see rendering of the page. I see the setups. Well, where's this tear down? I mean, the name itself helps you to test your code. So yeah, the private methods, they can be very descriptive. You can go crazy and make them long. I mean, if they're called just inside, it's not really a big much of a problem if you make them really, really long, as long as they have a nice, neat meaning, as long as there is not more than what should really be there. Oh, yeah. Has anyone seen a class with a name, right? So this class is named something, and then what goes inside that class is something else, something completely different. It's nothing that resembles the name of the class. Has somebody ever seen that? No?
Helper, utility, setup, helper, program manager, all that kind of names.
Right, but what happens in there when, like, you look at a class and the class is doing something that the name is in contradiction with? What happens with that is that people normally, they start prototyping some stuff, so they create a class, they give that class a certain name, and then they, okay, well, this didn't really work well, and so we're going to have to change the way that we're going, we're going to do something else in this class instead. And then they're just lazy, they don't rename the class, so that's how these kind of things go. By the way, recently, Sergey just renamed one entity that we had. It was called, for a mailing system, it was called store. So basically before we had, we were building messages for store, right? And then dispatching those messages. But then, rightly so, Sergey decided to change the entity from store to sender. because sender conveys much more meaning of what that thing, what that entity is doing. Because it has a higher level of abstraction. We can send messages not only from stores, but from other entities. It becomes much more flexible. It's just the way that you look at it. Sometimes kind of silly, but just naming something right, it makes you think in a completely different way, right? Because if I think about a sender, I think, okay, a sender is going to send something, right? If I think about a store, what store is going to do? Store maybe has a cart, maybe has some items, maybe has some orders, something completely different. Rightly so. So, which comes down to the point, when you see all this stuff, it's kind of obvious, right? Kind of common sense, what I'm talking here. You already know all of that stuff. But my empirical experience shows me that that's not really what goes down on the trenches, right? So, what is clean code? Clean code is when you can look at some code and then the code says something, you look at it, it's easy to understand, and it becomes kind of boring because you're always control-clicking that stuff, trying to find a mistake, and the code is defeating you because there's nothing wrong there. It's not doing anything else but what it's telling you that what it's the code or the function is meant to be doing. So, going on this battle and achieving halfway is to naming things right. So if we name things right, I mean, we have this concept and then we're going to try to do what the name tells us to do. So I mean, there's not much to go wrong from there. So yeah, so smaller functions, they are more focused and they become easier to choose a descriptive name. So if you have something very small, you look at it, I mean, there's not much for you to think about. Maybe you can take some time, please do so, take some time, sit down and think, what kind of names can I give it here, right? And then think again. And that's going to become easy for you to keep it small. Yeah. Don't be afraid to make a name very long, right? I think that's something that you can apply in pretty much all languages. Back in the day when I was using Fortran, Fortran would allow only six characters for a function. So, I mean, good luck with that, right? But we don't have such problems anymore, so I mean, unless you're working with assembly. But if you do so, I feel sorry for you.
Combo is for old versions of Combo.
Yeah.
You have this issue.
Well, maybe. I know that Fortran now supports more characters. I think it can go up to 60, if I'm not mistaken, but that depends on the assembly version that you're using, right? But maybe Kobo, I don't know. I was lucky enough not to touch it. So yeah, whatever you do in naming stuff, code styles, formatting as well, I mean just pick and choose, but when you choose something, follow that format. I have a teammate, one peer, he's very good with that. On my pull requests, he goes in there and he goes in, oh yeah, this name is not right. It should be like that. He's laughing because he knows it is. And rightly so. That is great. That is awesome. Because when we have code review, we allow ourselves to make the best code that we can build, right? And keeping things nice and tidy in the code is going to prevent us to just becoming sloppy. Because you see, oh yeah, that's another additional vertical line between functions too. Oh, yeah, screw that. Next time I'll just paste something from Stack Overflow with block formatting with another line and then, yeah, commit that, push that, yeah. No, we should allow ourselves to follow some kind of standard, right? Pick one, whatever you like, and follow that. As long as all the team is following the same thing, that's what I try to mean. It doesn't mean like just you are doing something, but the whole team, the whole company, the whole organization that works with that culture follow the same standards. Okay. Yeah, you got that. Yeah, I mean, don't be afraid for changing the name if you like calling something, then your requirements change, or you created another approach or extracted some methods, and you decided to change the name of something. I mean, don't be shy. Just change the name. What kind of IDs do we have here? Well, what are you guys using? PHP Storm? Yeah, cool. Do you know the shortcut for that? For changing the name, yeah, refactoring the name? Exactly. Shift F6 is easy. I mean, all the IntelliJs, they pretty much have the same shortcuts, and even if you don't use that, if you use something else, I'm sure there's a shortcut for that as well, right? So just rename it if you find a better one. If not, try to consult your peers, your teammates, see if they can help you out with something if you get stuck.
You better don't rename too much in JavaScript because it will mess up your code basically, but not give them profit. You will rename the comments, you will rename the configuration, and all of the stuff in the IntelliJ, for example.
Right.
I
We're going to try that. We're going to try that. So basically, when we are changing names, we are renaming things. We're sending messages to our future self. What happens is that, well, today I just sit down there and I have this task. I'm working on this task, and then I name that stuff. I put down some code in there. I finish my day. I have some other things to do. Next day I come back and then I look at that, and then I'm like, what? WTF this? WTF this? What is this? Hey, so be kind to yourself, be kind to your teammates, give proper names to things.
But also I think it's important to do the name changes in separate commits, because sometimes, okay, if it's you see you did a small change, but it changed like 100 files, just because you changed some name and not the logic in those.
Well, it could be, but that really depends on the policy that your team or your company or your group establishes for how to treat source code control, right? So how are you working in that? Are you working in the way that you have a pull request, and then your final pull request you have only one commit, or are you one of the guys that, rightly so, commit something, describe what you've done in there, and then in just one line where you have, first you have the ticket number of whatever you're working right now, and then afterwards a short description of what you've done, and then one line only, and then a description of your whole intent to be accomplished in that commit. If that is the case, then yeah, just create one commit just for that, saying, yeah, I didn't rename this because this and that, blah, 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 right? If not, that's going to be redundant anyway, because you're just going to squash everything and push just one single commit. And yeah, maybe you can add that in the, maybe in the message it will stay there, but yeah, it's really up to you and your group to decide if that really adds value. Yeah? Am I loud enough? No? Did I break this? No? How about now? No, let's say. Okay. So yeah, please use an IDE. Since I've started using an IDE, my life have changed. It was like seeing Jesus coming to me and saying, "There's so much greatness for you now, my son." Lord. By the way, there's one link here. It's free, so if you want to get down with PHP Storm and learn some really nice and cool things in there, please check it out. So okay, we already covered this. I think you had enough. I'll just give you this picture right here. This picture kind of gives you an equation for that. Right? So how can you measure it so that people, oh man, how can you measure the quality of the code that you write? It's simple. Very simple. That's how you measure it. So people look at your code and say, WTF, many times. you must be doing something wrong there. Prefer exceptions to returning error codes. So, we'll try to have a quick look at this. Well, breaking down a little bit easier, you can have a look at it. I've noticed that in many kind of IT presentations, what happens is the pattern that I've seen is that usually people go long, right? And most often they really suck, right? So when you have this combination, when they go long and they suck, that's dangerous. That's something really not nice. So I'll promise you, I'll try to, at least what I can at least promise is that I'll try to go fast, not long. So okay, we're going to see this, how we should try to trick these error codes, right? How we should try to get rid of them and only deal with exceptions so that we can prevent that kind of nested, nasty structure in there. So if you use exceptions, it becomes much more simple. Much more simple because you just issue some commands. What you have to do is something blows up, it's going to trickle up, and then you catch it and you apply whatever logic you want for that. Much easier than, much nicer than having that nested structure. Well, let's go. So, if we had a look at the first time, the first example, well, actually no, first of all, the second example that I've given you, what that block of code was doing is it was trying to execute something, applying some logic in there, and then handling that stuff. Well, that's not right. We have discussed over here. So basically, when I issue a command and I want to try and catch that block, because try catch block is ugly by itself, right? When you look at it, it really doesn't look nice. Try catch a lot of symbols, it's ugly. But what we can do in this way is just try, issue a command, and then if something blows up, we issue another command to handle everything that got blown. So, yeah. Wait. TDD. I won't be long with this as well. Right? So basically, when you write tests, your tests also should be with the same quality of the code that you write for production. I mean, it's not good enough so that you write some tests and then your tests are all messed up. They don't follow the same kind of order, same kind of structure, the same kind of cleanliness, the same kind of clarity. Production code and test code, they should be on the same level. So each test should also have just one assert. When you're arranging, so you have a test and then you arrange some stuff and then you act and then you assert. So that assert should be just one to prove the point of the test. So the test should also be first. It should be fast, meaning that you can execute your test very quickly. They shouldn't take very long to finish. And they should be independent, meaning that each test does not depend on the previous or on the next. And it should be repeatable. Whatever environment you have to run your test, that environment should be stable enough so that whenever you run your test, you have exactly the same outcome. Tests also, they should be self-validating. They should either fail or pass. And the tests also should be timely. What is timely? They should be slightly ahead of production code. So basically the idea, I know that sometimes we need to prototype, but ideally it should be, I write a piece of test and then I follow that with a little bit of production test, just production code just to prove the test. Right, so where do you go from here? Right. Okay, so yeah, maybe this word. So functions are verbs, they are commands, you issue a command, they should be named like that. And classes, they are nouns to whom which those commands are going to be issued to. So what is programming? Programming is pretty much the art of language design. So you're going to try to find a way to describe something, to describe a problem, and in describing that problem you achieve the goal that you wanted to accomplish. Where can we go from here? Things that are nice. I mean, I think I'm not as generous as the other mate here to give out a book, but maybe I should be, because this one is really worth it. So yeah, so please, if you can get your hands on this book is marvelous. I really recommend it. Ask it for Christmas. You should also practice. I mean, these things are not because like I listen to somebody telling me something. I mean, I know it takes time. You have to try to prove this thing. Try. Give it a good try, right? Because these kind of things don't come easy. Still developing this kind of approach. And another thing really cool for you to develop and build really nice, neat and clean code is to have code reviews. So whenever you're doing something, you make a pull request and then somebody else comes and trying to find something wrong with your code. Anything goes, anything goes. Is there a typo there? Is that one vertical space is wrong? Horizontal space is not wrong, because that adds up to that broken window policy. Right? Who knows about this broken window policy, something research conducted in New York? Do you know about that?
Yeah.
Yeah? So what does that say?
It says that if the windows are not broken, then everything stays okay with the building. As soon as you broke the windows, it gets other things done to it.
Right. That's the basic idea. So I'll just restate that. Right. So basically, the idea of broken windows policy, something that was applied in New York by Mayor Bloomberg, was that they started to realize that humans are animals. We are funny creatures. And what happens with us psychologically is that it's proven that if you see something, okay, I'll behave. If you see something that is broken, something that is out of order, you have this tendency to not respect it. And just throw some rubbish, break another window. But in another case, if you see something very nice and neatly and everything nice, I mean, you're just going to try to follow that path. I mean, your tendency is to follow that path. It becomes much easier to keep the standard, right? I mean, who has ever gone to Switzerland? Switzerland is great. I mean, it's so clean, so shining clean, the streets, that if you're ashamed, if you're bad, if something drops out from your pocket, nobody saw me, I'll pick it up, put it back in. So that's how you should treat your code. I mean, that's how I believe that you should treat your code. It's not easy. We're all humans, we make mistakes, but we should be there in the pull request, in the code review to pick each other up. And yeah, I already said I'm from in Texas. We are hiring, by the way, if you need a job, if you want to work with, not me, but some other great professionals from whom I've learned a lot. Please come have a chat. Questions? Don't be shy, come on, if you have questions, maybe I'll have your answer, maybe not, maybe we can find it together.
Does your principle, oh sorry, go ahead.
I personally don't understand and hate the situation when I see one function that sort of does something, I control click on it, and then it calls another function, and then there's another function. What is that? I kind of hate it. I have to go deep in and see one function calling another function and just like...
Try testing as a function. Write a test for that function.
Okay.
You will understand. Because when you write a code and you have the big function doing all that stuff inside, when you try to write a test to it, it has so many dependencies and stuff like that, so you have to mock them and do some nasty stuff to get your test done. This is really bad thing. So when you split it into smaller functions, the freaking easy to test.
Yeah, well, I get the splitting part, but I've come up with situations where there is like only one function inside that one function.
Right,
I
but
find it confusing.
yeah, so basically we have to go back and look at that stuff that I was saying. So you have to look at the function and you see what kind of levels of abstraction are in there. I mean, when you call that function, go inside that function, then you see what that function is doing. Is it, so that function now is a callee, right? It's callee meaning that it's being called by a caller. So if I look at the, so if I look at the callee, right? This callee, is it doing exactly the same that the caller is doing? So if that is so, then maybe it's not the right decision to extract that. In addition to that, I can add to his comment. I mean, I kind of understood the concept, the idea. Maybe you did as well, but let me see. Let's just double check that, right? So basically, what he was trying to say, if I got it right, yeah, correct me if I'm wrong, is that you have classes, right? Those classes, through the principles that Meti here was telling you, solid, right? So we all know that solid. Now we know, right? The solid. How you organize your classes, right? So if they are separate entities, right? So your function is probably, if you have dependencies, going to flow from one point to the other. And rightly so, if your class shouldn't be very, very big. It shouldn't have many properties, because when you look at a class and that class has many properties, it most definitely means that that class is not doing just one thing. It's probably doing a lot of things in there. Now not talking only about the function, but the class itself. So if you look at a class and then see a lot of properties, maybe that class is doing a lot more than what it should be doing. Right? So maybe you have to extract not functions, but classes. You want to talk?
No, I just wanted to add maybe to the question. When you debug your code, for example, I think with the approach of one line per function, there would be stuck traces like 300 entries long. So it really be hard to understand what's wrong, you know, when you're control clicking, as we said, and go deeper and deeper and deeper. So maybe this strict rules of the approach is very sound, but the strict rules like one line per function, one line inside each, maybe does it actually make sense? What is your stack trace length, like size of that trace?
Oh, if we look back on this, right, you're going to have a class. That class shouldn't be very large, right? Should have a group of functions, not too many functions, just the right amount, right? And then you're probably going to have 1, 2, 3 public functions, right? And then those public functions are going to have some private functions, not too many, right? And then if you're going to mock, right, you have to mock the dependency so that when you test that class, when you test you test only the public function, right? So the private functions, you shouldn't really test them. They should be tested through the outcome, through the combinations of possible entries and exits of the public function, right? Because if you use reflection to test something, you're definitely doing something wrong there, something very wrong there. So, I mean, I kind of find it a little bit hard to have such a stack trace. I mean, like, of course you're going to have stack trace because there's one function calling another function, but if you're within that scope of a class, I quite find it hard that this stack trace is going to be such long that it's going to cause you problem. I mean, maybe it's just a way of organizing classes, extracting functionality into other different classes so that you can mock them separately, so that you can test them separately. Right? Maybe you should try that way.
I think sometimes there's this principle you're not going to need it, or principle. So it's sometimes people over-architect because thinking, okay, in the future I will need it. I have this extension point, but you never need it. So you end up with those one-line functions because you thought, okay, it will fill up later, but it never does. So I think it's also a good, sometimes good thing. Okay, maybe if I don't need it tomorrow, maybe, oh, okay, if I need it tomorrow, I'll add it tomorrow. Today, I'll keep it as simple as possible. Not for maybe high-level architecture, but for some parts of the application, you can definitely do like that.
Well, I believe that we should kind of mirror the principles from Solid to inside a class as well, because you're talking about the micro inside the class, but then you should be open for extensions, but close to changes, right? So I think that you shouldn't try to over-architecture things inside the class. I mean, if you don't need it today, I mean, why are you going to do something that you don't need today?
Yeah, I think.
I mean, perhaps you should do something in a way that tomorrow you can add something, tomorrow you can modify something, tomorrow you can maybe just have a different option or something. Maybe you're talking about switch statements, right? Because when you have some switch statement, that's horrible. Switch statement, it duplicates, it moves from one class to another. So you have a customer, if this customer is from Africa, then give him this $100. If he's from Latvia, then give him 0.5, meaning that the product will be cheaper for you. And then if from this country, do that. And then you have to copy-paste that switch statement to other places. So in that case, switch statement should be buried somewhere deep in the system, where it's probably inside a factory, right? Probably inside a factory that generates you all those objects, different objects that relate to all those different types of customer, right? And then you can just issue a command. You don't need to know what kind of object is that. I mean, as long as they agree to a contract that they interface, then you can just call it, and you know you'll be sound.
I wanted to add a bit about extension point, and if you follow the path where the function does one thing, these things don't come up because it fits naturally in that function. It comes up naturally. You don't have to artificially add another function layer because it's just there because you have to do one thing.
Right. Any more questions?
About static code analysis, I think some of these things can be called by some tool like.
Yeah, definitely. Yeah, quite right. What we use at Intexis, we have a code sniffer, so that before we and I'm pretty much sure you can use that in other something similar, static code analysis for some other languages. So what really happens is that you commit something and you try to push your code, but then this code goes out to the repository, and then before it gets accepted, this static analysis goes on through your changes, and then it looks at your code style, all the rules that you have, and then if something is not correct, it violates those rules, then it gets rejected.
Okay,
so that's how we do it. Yeah, am I wrong?
No, you're not wrong. So one comment that probably you shouldn't go too small. You should apply some common sense to not just checking the if statement and calling some other function. You can take example from Symfony or Doctrine. There is a method that executes a query. So it does logging, preparing, and executing, 3 things. But in general, it does and execute the query. So I think you shouldn't go too small. Just checking the if statement, calling that, inside that, checking that, and so on.
Yeah, that's one part.
All the middle.
And renaming all the time. So you add a tiny thing to your function and think, okay, it's now does logging as well. So it's render HTML page with test, tear down, startup, and logging, and something else, and something else. I think there are some rational limits to be applied.
Well, that kind of varies. Depends on how you structure your code, really. I mean, what you can rename like crazy are private functions, right? Because those private functions are only going to be used within the context of your class, so you can just change it. You're not going to blow anything up, right? I'm not talking about public methods, which are going to be called by other places, those methods, maybe you shouldn't change them so much, right? Because other people are using them. So if you change them, maybe you have to notify other people that you have changed that, and then they have to do it as well. So in the sense that it's best for you to change your private methods, right?
Okay, if you have some
Okay.
more questions, please come to me.
Yeah, come out and chat if you're looking for a job.